All right, let's look at some example problems dealing with trig. First thing I want to do is find the equation of the line that's tangent to the curve y equals e to the x cosine x at this point. Okay, so let's see, the derivative then is going to be, got to use the product rule on this, so it's going to be e to the x times negative sine plus cosine x times e to the x. And on this one, I am going to factor out e to the x. So you got e to the x times cosine x minus sine x. Okay, they've given us the point here, so really all we need to do is come up with the slope and then plug into point slope form. So the slope is going to be y prime evaluated at x equals 0. That notation is used sometimes to mean whatever this expression is evaluated at this value of x. So this is going to be e to the 0 times cosine 0 minus sine 0. And that is, e to the 0 is 1, cosine of 0 is 1, sine of 0 is 0. So our slope here is 1. So our line is going to be, let's see, this is our x1, y1. So our line is going to be y minus 1 equals 1 times x minus 0. So I just get y equals x plus 1. Kind of a boring line, but let's graph it just to see that this is the correct answer. So let's see, our function was y equals e to the x cosine x. All right, so this thing, it makes good sense. It's sort of the cosine graph, but over here the oscillations get bigger and bigger, and over here on the other side they get smaller and smaller because of e to the x growing small. All right, so the point is 0, 1. So that's the point we're supposed to find the derivative through, or the tangent line through. And we came up with the tangent line was y equals x plus 1. And sure enough, that's it. If you zoom in and look at it, that's the tangent line. All right, let's do the next problem. Find the derivative of this thing. All right, the derivative of this, we got sine for the first and cosine for the second. So f of x, or rather f prime of x is first, times derivative of the second, it's minus sine t, plus second, times derivative of the first. So this is minus sine squared t plus cosine squared t. And that's pretty much it. You might be tempted to change this into 1 or negative 1 or something, but you can't do that. If this negative weren't there, I'm going to erase it temporarily. If that negative were not there, then this would give you 1. But this negative changes things. If it were minus sine squared minus cosine squared t, that would give you negative 1. But the fact that they're mixed there, this doesn't give you either one. If you look, this is equal to cosine of 2t. I wouldn't really expect anybody to write that for their answer, but it's possible that the book might list that as the answer. And if so, you'd want to look at it and figure out, is this the same? And there are two ways you could do that. You could look for an identity. The other thing you could do is you could graph both of them and see if they give you the same thing. Let's do that. What are the two things we had? Minus sine squared t plus cosine squared t. Wait, minus sine squared t plus cosine squared t gives me that. And if I graph cosine of 2t, let's see, it doesn't like that for some reason. It wants a y equal there. This. There we go. So yeah, these two graphs, these two functions have the same graph. So they are equal to each other. All right, let's do the next example. There we go. Find all values of x for which g of x equals sine x has a slope of 1/2. All right. The calculus here is the easy part. It's solving the function that we get from it that's going to be the difficult bit. Because the derivative here, g prime, is cosine x. And so then we just have to solve cosine x equals 1/2. And different people learn how to do this in different ways. Some people use the unit circle. I just remember my special angles. One of the solutions to this is x is equal to pi over 3. Let's see, what else do we know? All sine, tangent, cosine. So down here is another quadrant where we'd have a solution. This over here tells me that all three functions are positive there and cosine's positive there. So this would be negative pi over 3. And both of these I'd add plus 2 pi in onto. So that will give us all the solutions to this. All right, one more. A frictionless mass on a spring is moving back and forth. So I've got a picture here, and basically what happens is it's like you pull the mass out, and when you let go, it springs back and forth. So it goes back and forth for, well, if it's frictionless, it would go forever. But anyway, that's getting into the physics of it. But it says the position of the mass is given by this function here. And if you want to get technical about it, that's the position relative to some place here where like is the natural length of the spring. So find the functions for the velocity and acceleration. Okay, this should be pretty quick. The velocity is just the derivative, and derivative of this is going to be 2 cosine t, and the acceleration is the second derivative, which is going to be negative 2 sine t. Let me back up. It's 2 times the derivative of cosine, which is negative sine t, which I would write like that. All right, that's it.